Here we have the polymerization of ethene. How does ethene polymerize to become polyethene? Let's start to find out this. We have the stage number 1. I use phenol to make what? To make starting this reaction. So here we have the ethene is an alkene with the formula of C2H4. So the double bond makes it reactive. If I press the double bond, it will break by helping what? Helping with what? With the phenol. Let's go to C. If I double bond, if I press this bond like this, we have what? We have the bond will be broken to make what? To make open the chain in this molecule. So the double bond between the carbon atom is broken to make 1 or 2 open the chain to make connection with another molecule of what? With another molecule of ethene. So the second one, if I have another ethene monomer, that's the bond that broken like this and make one connection between these two molecules to form double molecule to form one chain, and we have this is called addition polymerization. And we have another one of this compound or this molecule that's broken again to make this chain more than one time, more than 100 times, to make what? To make the polymer chain grows as more ethene monomers bond together. So here the stage number 4, here again we have the polymer chain grows as more ethene monomer bond together to make long chain, and this is called polyethene. And we have another one, another stage, we have branching of the occurs at high temperature and the pressure, or the catalyst that we use the phenol here to make what? To make one hydrogen atom that move away from the carbon and another molecule of ethene that makes what? Makes connection with the carbon atom here to make another open the chain. That's what? That's perpendicular with the first one. Again, we have the branching occur at high temperature and the pressure, or if the catalyst it is not used. So here we have the catalyst, if not used we have high temperature. So I use the phenol to start this chemical reaction and speed it. So here this is the catalyst, it is not used. So the one atom of hydrogen that move away to complete the chain or to close the chain from the left hand. And we have another compound or another molecule of ethene that makes connection with the second carbon atom in this chain to make another polymerization. And we have another one. The polymerization reaction, it's what? It contains or continuous, and polyethylene is formed like this. We have many balls that connect to each other to form what? To form one line that called colony. It is like the colony. Colony here it means one line that contains many of these molecules of ethene to form what? To form polymer. So the uses of the phenol that start this reaction to complete in this way. So here we have it is an organic compound. This is phenol. It's carbolic acid. It's the organic compound that has a great industrial importance as we're starting the material in making polymers. Polymers, we use it to make pipes of water. We have some kind of plastics like bags, like anything that use plastics. Plastics, it's one of the types of polymers that we use it to make many things. Like what? Like pipes, like bags, like some kind of pencils, anything of this. We have the preparation of phenol. Preparation of phenol is very easy to know it. Preparation of phenol, it's what? C6H5Cl. It means chlorobenzene. We add some amount of NaOH to chlorobenzene. We have NaOH, sodium hydroxide. That makes a reaction with chlorobenzene. And we have double substitution here. You know double substitution reaction from the secondary. You have double substitution reaction between OH group and Cl. So at high temperature and high pressure about 300 atmosphere, this reaction takes place. Why? Because here phenol, it's difficult to make reaction in the normal way, in the normal condition. So I have temperature, I prepare the phenol from what, or under high temperature, and the high pressure equal 300 atmosphere. So the chlorobenzene plus NaOH, it's give us what? Give us C6H5OH, it's called phenol. And we have NaCl, sodium chloride solution. So here this is what? This is the preparation of phenol. Now we have a video about what? About preparation of phenol and some properties of alcohol. Let's go to see this video, and it's very interesting one. Let's go. We have here the phenol. Phenol, it means the compound that we use it in many industry. We have here add few milligrams of phenol. We have some kind of reaction that's happened by phenol. So we have this small amount of these phenols and add some amount of what? Of catechol and some amount of pyrogallol like this to make what? To make differences between them. The difference between these types, phenol and catechol and pyrogallol. So they dissolve phenol in water. Dissolve phenol in water. So it doesn't dissolve in water. And we have another one of the catechol and another one. We have another reaction that's 1 or 2 drops of FeCl3 to make what? To make reaction. It has violet color that appears like this. So it is the reaction of phenol and pyrogallol and catechol with what? With this compound. And we have many one of them. Catechol, it has green color, and we have phenol, it has violet color, and the other one that has blue color. And the first tube, a drop of aniline, red color, of the phenol to make what? To make this reaction. So this the reaction until dissolve HCl that dissolve inside. So here a few drops of HCl to make what? To make reaction here. So we have different thing here that's happened. We have the reaction that's happened between the 3 types of this compound. And we have what? We have this reaction, and they have what? They have the same color here. So we have the physical properties of phenol. Physical properties of phenol, it is a solid corrosive substance. Corrosive substance, it means what? It means it is a type of substance that absorb water from our skin. Like what? Like hydrogen sulfide or hydrogen sulfate or concentrated acids. So, or another one, we have NaOH concentrated. This is caustic soda that makes corrosive substance. It means absorb the water from skin. So it is solid corrosive substance, and it has characteristic odor. Characteristic odor, it means what? It means it is a special type of odor of what? Of phenol. So the from the physical properties of phenol, it's what? It is the solid corrosive substance, and it has characteristic odor. Characteristic, it means a special odor of this compound. And we have another thing about these physical properties, and it melts at 43 degrees centigrade. Again, the physical properties of phenol, it melts at 43 degrees centigrade, and it is springly soluble in water. It doesn't dissolve in water fast. Why? Because phenol, it appears like oil. So the phenol in water, it makes a layer like oil. So it has less dense than water in some kind of this dissolving. So the physical property of phenol, it doesn't dissolve in water easily. So it melts at what? At 43 degrees centigrade, and it is springly soluble in water. We have from the physical property of phenol, we have solubility in water increases by increasing the temperature. If you have hot water, it dissolves easily. But if I have cold water, it doesn't dissolve in cold water. So the solubility in water, it increases by rising temperature. It becomes completely impossible or immiscible in water at 65 degrees centigrade. Again, here we have the cold water and the phenol doesn't dissolve inside. If you increase the temperature gently, it doesn't dissolve also, but at 65 degrees centigrade it's completely miscible in water. So the miscibility of this phenol compound, it's at what? At 65 degrees centigrade. So if you have an exam and write the physical properties of phenol, or two or three properties of phenol, you must write these things, okay? And here we have, it's very important to know this, it becomes completely miscible in water at 65 degrees centigrade. After that, we have it has acidic property. Why? Because here we have the presence of H proton, but mister, we have here OH with that attached, or hydroxyl group that attached with benzene. What will happen here? Here we have the benzene ring, it makes attraction force with what? With the oxygen. So the hydrogen is very easy to lose from what? From the oxygen bond. Again, we have OH bond here. OH in hydroxyl group, it's very strong, but here in phenol, the attraction force of the benzene ring for the electrons on the O, or the oxygen atom, it makes the hydrogen, it's freely to move outside this compound. So the acidic property due to the presence of hydrogen proton here. It reacts with sodium metal, forming hydrogen gas, as we see here. Here we have the chemical properties of phenol. Due to the polarity of OH, it means what? The polarity of OH, it means hydrogen, it has positive proton, and the oxygen, it has negative what? Negative charge. Here the bond, it increases by the presence of benzene ring. Benzene ring attract the electrons of oxygen atom, and they make the hydrogen is free to move out from the compound. So here in this reaction, if the phenol react with sodium, for example, so we have sodium, this benzene ring, it makes hydrogen move away or evolve from the reaction. So the sodium replace hydrogen here to make what? C6H5ONA, sodium phenols, sodium compound with what? Sodium salt of phenol. So here this sodium, it's replaced the hydrogen to form C6H5ONA plus what? Plus hydrogen. So the hydrogen is evolved from this reaction. It's very important to know the chemical property. Why? Because we have in the exam, we have a question about what? What is the effect of sodium with phenol? So I must write the reaction like this. C6H5O6, or benzene ring with OH, plus Na give us C6H5ONA, plus what? Plus hydrogen that evolved from the reaction. So the sodium substitute hydrogen from the phenol here. Why? Or give reason? Because we have the hydrogen is freely to move, hydrogen proton is freely to move due to the effect of benzene ring that attach the electrons of oxygen atoms. We have another chemical property of phenol. It doesn't react with HCl due to the strong bond between oxygen and the hydrogen in hydroxyl group. It's different, completely different here. We have it doesn't react with HCl, yes. Why? Because it has acidic property of phenol that contains hydrogen proton that move freely from what? From this compound. Again, so the two acids here, HCl and what? And the phenol doesn't react to each other because the strong bond between hydrogen and oxygen. So what? We have it's impossible to eliminate the hydroxyl group from phenol during reaction with acids. Again, you must understand this. It is impossible to eliminate, to move out the hydroxyl group from the phenol during what? During reaction with acids. Why? Because phenol, it has acidic property like acids, like HCl, like H2SO4 and so on. So it is very, very impossible to move out this hydroxyl group. Due to what? due to the strength or strong bond between oxygen and hydrogen in the hydroxyl group. Hydrogen and oxygen, they are very strong to bond to each other or together. Why? Because we have one of them, the hydrogen is positive and the oxygen is negative, so it makes the attraction force between them very strong, and it is what? Covalent bond. Covalent bond is very strong, or stronger than any type of bond. We have nitration of phenol. What's meant by this? Phenol react with concentrated nitric acid. Concentrated in nitric acid. The acid here, or the nitric acid, it is one of the acids that makes reaction with phenol. So, in the presence of sulfuric acid. Why? Sulfuric acid, it makes what? It makes the absorption of water from this one, from the reaction. If I have water in this reaction, sulfuric acid absorb it. That's helped to absorb water from the reaction and form 2, 4 and 6 trinitrophenol, which is known as picric acid. Nitration of phenol. Here we have the reaction. Phenol plus HNO3 give us what? Give us 2-nitrophenol. And the hydrogen or hydroxyl group, it's in its place, doesn't move or doesn't replace. And we have NO. That makes what? This NO makes what? Makes the reaction. Makes the reaction here and substitute one hydrogen atom. Why? Because here the hydroxyl group that pointed or direct this compound or this group NO to the second one, the second carbon atom of the benzene ring. It directs it like this. So the first one, we have 2-nitrophenol plus H2O, and we have phenol, okay, that makes reaction with another HNO. So it has what? It has 4-nitrophenol. 4-nitrophenol. Why? Because OH, it makes direction or change the direction of NO, pointed it to what? To NO2. So the OH give us or make the NO2 group, nitro group, in what? In the 4 position of the carbon on the carbon number 4 in the benzene ring, plus what? Plus H2O. So in the last time we have what? We have the hydrogen, or we have phenol that react with 3HNO. So here the NO2, it makes direction in 2, 4, 6 trinitrophenol. It's called picric acid. So this reaction that's happened here, because what? Because we have the OH is found in benzene ring. If I have no benzene ring, we have this substitution of the NO2 nitro group by what? By the hydrogen atom from any one of these carbon atoms. So here the OH or hydroxyl group pointed this NO2 to 2, 4 and 6 plus what? Plus 3H2O. Dear friends, I hope to enjoy your time with us. Till we meet again in another part of organic chemistry. Till we meet again, thank you and goodbye everybody.